Hello students, today we are going to start a new chapter, chapter 2, which is known as polynomial, and it is for class 9. This is the first lecture of this chapter. So you will watch this video very carefully. In this, first of all, we know, and I can say you are familiar from previous classes about constant, variable, like this, and some expression also you are familiar with this. In this section, in this class, we are going to study about an expression which is in the form of a0 plus a1x plus a2x square plus plus an x to the power n. Such type of expressions are known as polynomial. So for polynomial, in this expression, a0, a1, a2 and a are real numbers. These are real numbers. Real numbers. Real numbers. And especially a0 is known as constant. Constant. It is known as constant. And the power of the variable x, n is whole number. So such type of expression we will study in this section. So what is constant? Here x, in this variable is x is the variable. So what is variable? We will know about this variable, constant. So there is a symbol which contains fixed value, which takes fixed value. The symbol which takes fixed value is known as constant, and the symbol which takes many value is known as variable. So these are the expressions. Now we take some more examples. For example, suppose we take 2x, 3x square plus 5x minus 3, 4x to the power 5 plus 3x cube plus 4x square minus 5x, like this. These all are the polynomials. These all are polynomials. Why they are polynomial? Polynomial. For being the polynomials, we are observing here the exponent of the variable x is 1. In all these polynomials we are looking, there is only one variable, and which is x. In this polynomial there is only one variable x. In this polynomial there is only one variable x. In this also x. So these are known as polynomial in one variable. What is this known as? Polynomial. Polynomial in one variable. In one variable. In one variable. And since it has only one variable, and which is x, so it is also known as polynomial in one variable and in x. Polynomial in x. Suppose we write like this: 4y square minus 3y plus 2. This is also the polynomial, but this is a polynomial in y. This is known as polynomial in y because variable is only one variable. So this is polynomial in one variable. Also it is known as polynomial in y. So for being the polynomial, first of all, we observe, we look the exponent of the variable. In this exponent of the variable is 1. In this exponent of the variable is 2. In this term 1. And in this term it may be written as like this. Exponent of the variable is 0. So in each term, exponent of the variable we observe carefully like this, and we are looking all the exponents in each and every term are whole numbers. Here 1, 2, 1, 0, 5, 3, 2, 1, 0, all are whole numbers. If the exponent of the variable in each term, not any single term, in each term should be whole number. Exponent in each term, एक भी term fail नहीं करना चाहिए. In each term should be whole number. Only then the expression, that means algebraic expression, is a polynomial. So this is the identification of polynomial. In this way we identify the polynomial. All the polynomials are denoted by like this, fx. Any polynomial can be denoted by fx. Suppose I want to denote this polynomial, so we can write fx equal to 2x. Suppose I want to denote this polynomial, we can define px equal to 3x square plus 5x minus 3, like this. So px, qx, rx, in such type of notation is denoted for polynomials. Now we take other examples. In this you are looking polynomial 1, 2, 3, 4, 5. There are 5 terms, that is 4x to the power 5, 3x cube, 4x square, minus 5x and 3. All are known as terms of this polynomial. Suppose this polynomial is denoted by fx. So we can say these are the terms of the polynomial fx. In short, we can denote like this. These are the terms of, and terms also we can write like this: 4x to the power 5, 3x cube, 4x square, comma, minus 5x, comma, 3. So these 5 are these 5 terms. There are 5 terms in this polynomial fx. Now I want to know 3 is the constant term, minus 5 is the coefficient of x. This is known as minus 5 is the coefficient of x, and 3 is known as the constant term. Or we can say 3, if we write like this, then 3 is the coefficient of x to the power 0, and it is also constant term. 3 is the constant term. Minus 5 is the coefficient of x, 4 is the coefficient of x square, 3 is the coefficient of x cube, 4 is the coefficient of x to the power 5. So in this way we identify the coefficient. Now degree. Before this we define definition for the polynomial. What is polynomial? Polynomial. We take a definition: an expression which is in the form of a n x to the power n plus a n minus 1 x n minus 1 plus a n minus 2 x n minus 2 plus dot 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 plus a2x square plus a1x plus a0, like this. That means power is in descending order. Its power is descending by 1, like this, and at last its power becomes 0. So here a0, a1, a2, an minus 2, an minus 1 and an are real numbers, and n is the whole number, and it is known as polynomial. An expression which is in the form of this, where a0, a1, a2 dot 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 an minus 2, an minus 1, an are real numbers, and n is a whole number. Is called a polynomial. So this is the definition of polynomial. Now I want to explain some more thing. In this you are knowing an x to the power n, an minus 1 x n minus 1, an minus 2 x n minus 2, a2, a1 and a0 are known as terms. These are all known as terms. And an is the coefficient of x to the power n, an minus 1 is the coefficient of x to the power n minus 1, and in this way it is x square left. So we can write like this, a1x and this. So these all are the terms, and a2 is the coefficient of x square, a1 is the coefficient of x, and this is the constant term. a0 is known as constant term, in which there is no any variable. So these are the. Now we take some examples. One more thing. This n is the maximum power of the variable. So this is also known as leading term. And its variable an is the leading coefficient. Maximum power of the variable, that term is known as leading term, and its coefficient is known as leading coefficient. Now we write, suppose 5x to the power 3 minus 2x square plus 5, like this. So this is the polynomial, and it is in this form, because power of the variable is in descending order, and it is descended by 1. That means 3, 2 and 1. So here power of the variable is not 1. So we can write like this. If it is plus 5, then we can write like this, 0x plus 5. That means you can say initially it was this, and it may be written like this, 5x cube minus 2x square plus 0x plus 5, like this. It is written in this form, because this is the leading term, because it is the maximum. 3 is the maximum power of the variable. So this term is the leading term, and 5 is the leading coefficient. So coefficient of x cube is 5, coefficient of x square is minus 2, coefficient of x is 0, and this is a constant term. So if this expression is written in front of you, and if I ask you what is the coefficient of x cube, you will say 5, coefficient of x square minus 2, and coefficient of x, what will you say coefficient of x? Coefficient of x is not in this, so we can write like this and we understand like this, coefficient of x is 0. If any term is absent, then its coefficient will be 0, and 5 is a constant term. Now we take some more examples. We take x to the power 3 by 2 plus x square minus 5x plus 2 root 2x plus 5x to the power minus 3 plus 3x square plus 2 1 by x plus x square, like this. Such type of polynomials you are looking here. Exponent of the variable is 3 by 2, exponent of the variable is 2, exponent of the variable is 1, here exponent of the variable is 0. So all the exponents are not whole numbers, only 3 are whole numbers. It is fractional number. So for being a polynomial, all the exponent must be whole number. If any exponent fail to become the whole number, then that will be not the polynomial. So this is not the polynomial. In this also, here exponent of this variable is not the whole number, minus 3 is not whole number. It may be also, here it is whole number, here it is whole number, but here it is not the whole number. So it is not the polynomial. 1 by x, it may be written as x to the power minus 1 plus x square. In this there are two terms. So in each term, coefficient of the variable is, an exponent of the variable is not the whole number. In this it is not whole number, it is whole number, but whole number must be both, then it will be the polynomial. So for the identification of polynomials, we must observe the exponent of the variable in each term, and if in each term exponent of the variable is whole number, then that will be the polynomial, otherwise not. These all are not the polynomial. We take one more type of polynomial. Suppose this is 2, this is 3, minus 4, 5, like this. These all are the numbers which are non-zero numbers, non-zero integers. These are non-zero integers. It may be written as 2x to the power 0. It may be written as 3x to the power 0. It may be written as minus 4x to the power 0. It is known as written as 5x to the power 0. So all these numbers have been written in this polynomial form. So it is only one term, and it is single term, and it is also the polynomial. This is polynomial in one variable. This is also polynomial in one variable. So all are polynomial. So we can say all the constant, that means all the numbers, all the real numbers are the polynomial, and they are known as constant polynomial. Constant polynomial, because we can write in the form of polynomials. If I ask you, if it is polynomial, then what is the degree of this polynomial? Degree of polynomial is 0. In this, degree of polynomial is 0. In this, degree of polynomial is 0. Degree is 0. It is also known as constant term. The term in which exponent of the variable is 0, it is known as constant term. So all are polynomial, but they are constant term. So these are the constant polynomial. Every numbers are known as constant polynomial. We take, other than this 0, we take 0. These are the non-zero integers, and this is the 0. 0 is also the integer. So this 0 is not the, this 0 is known as, this 0 is known as 0 polynomial. 0, it is also polynomial, but it is zero polynomial. This is known as zero polynomial. And since this is polynomial, then its degree is 0, its degree is also 0, its degree is also 0, but zero polynomial, degree of zero polynomial is not defined. Degree of zero polynomial is not defined. Why? Because 0 may be written as 0x to the power 1, 0 may be written as 0x to the power 2, 0 may be written as 0x to the power 3. In this way, this is the fixed one number 0, and it may be written in various forms. So if we write this in this form, then its degree will be 1. If it is written in this form, then its degree will be 2. If it is written in this form, its degree will be 3. So what will be the degree of 0? What will you say? This is confusion. So that's why degree of the 0 is not defined, it is not fixed. So you will write, you will know in this, in your mind, the degree of zero polynomial, degree of zero polynomial is not defined, like this. Now one more thing. 2x, 3x plus 5, 4x plus 3, and 4x plus 3. These all are the polynomial, and it may be written in the form of ax plus b. So it is 2x plus 0, and it is already in this form. So degree of this polynomial is 1. So it is known as linear polynomial. So all the linear polynomial whose degree is 1 may be written in this form. That must be written in this form, ax plus b. A polynomial which is in the form of x plus b is known as linear polynomial. So today's session is finished, and in the next session, in the next class, we will study about zeros of polynomial. Zeros of polynomial. This is a very big chapter, so it will contain more video. In the next video, we will study zeros of polynomial, and you will not forget to watch this video. It is more informative. Zeros of the polynomial and more other content will be explained. So now I finish this, and if you are first viewer, then you will subscribe this and share also. Thank you very much.